All right, guys, today we're gonna put together our last two units, our last two lessons, sorry, and we're gonna use a matrix to help us solve systems of equations. Now, this can be done without a calculator, but it's not actually any faster than solving it analytically. But if you have access to a calculator, which we will be using today, we can really save a lot of time on solving some of the large systems of equations using a calculator. Now, if it's just a two-variable system of equations, I think solving using algebraic techniques, substitution and elimination, is faster than using a calculator. But if it's more than two variables, solving using a calculator will be much faster, and there are fewer opportunities to make mistakes. Now, you can only use this method if you have a calculator to save you time. So you still need to know how to do it algebraically. Let's get into this. Before we get into what we're gonna do, we're gonna start by making sure our multiplication skills are good, because we're gonna need them today. So multiply 5, 7, 2, 3 by 3, -7, -2, 5. And the first question is, can we multiply these? And to see it, we need to look at the dimension. This is 2 by 2. This one is 2 by 2, and what we're looking for is, do the middle dimensions line up? 2 is equal to 2, and so we can multiply them. And the leftover dimensions, that is the dimensions of the answer, so 2 by 2. So this will have A11, A12, A21, A22. These will be the 4 elements. So what are these elements equal to? Well, hopefully you see that A11, the way we get it, matrix multiplication is weird. The way we get it is we multiply the first row times the first column, and that will give us the first row, first column. And the way we multiply a row times a column is we multiply the corresponding elements. So the first thing in the row times the first thing in the column. 5 times 3. And then we add in 7 times -2, the second thing in the row times the second thing in the column. 7 times -2. And so this is 15, this is -14. 15 plus -14 is 1. And so there will be a 1 in the first row, first column. Then we will need to do the second row, second column. So first row, second column. Oh man, I'm trying to use a pen that is dead. That's not good. Let's try this. First row, second column. So that will be the first row, second column of the answer. So A12 will be the first row, second column. So first row times the second column, and we do the first thing times the first thing, 5 times -7. Then we do the second thing in the row times the second thing in the column, which is 7 times 5. 5 times -7 is -35. 5 times 7 is 35. -35 plus 35 is 0. So 0 is the first row, second column. Now we're on to the second row. So the second row times the first column. We multiply the row times each of the columns, then the next row times each of the columns. So here, 2 times 3, so this is A21. The 2 times the 3 is 6. 3 times -2 is -6, and that is 0. So the first row, second column is 0. And lastly, we're going to do the second row times the second column. And when we do that, A22 will be 2 times -7, -14, and 3 times 5, which is 15. So -14 plus 15 is 1. Now, this is a special matrix that we should recognize. What is this special matrix? This, I hope we recognize, is the identity matrix. It is the matrix that if you multiply the identity matrix times any other matrix, it'll give you back the same matrix you started with. So when there's 1s along the main diagonal and 0s everywhere else, that's the identity matrix. So hopefully we remember that. It's a special matrix. All right, this next one, multiply this times this. And the first question is, can we multiply it? And hopefully we recognize that this is a 3 by 3 matrix. This one it has 3 rows and only 1 column. So it is a 3 by 1 matrix. So can we multiply this? Well, the dimensions on the inside are equal to each other. 3 and 3 line up, so we can multiply it. The leftover dimensions are going to be the dimensions of the answer. So the answer the result matrix, the product, is going to be 3 by 1. It's the leftover dimensions. And so how do we get them? Oh man, I didn't leave myself enough room here. Well, we're going to multiply the first row times the first column. 1 times A plus 2 times B plus 3 times C. And this is going to say just A plus 2B plus 3C. I wish I had let myself one row. Now this is all one element. Even though it looks like it's a trinomial, but it's all a single element in the matrix. Okay, adding things together doesn't make it more than one element. Next, we're going to multiply the second row times the column. We're going to get 5, the first thing in the row, times the first thing in the column, 5 times A, plus 7 times B, plus 9 times C. So we get 5A plus 7B plus 9C. And the last row times the last column, we'll get A times 0, so 0 times A, plus 2 times B, plus 4 times C. And when we put this in, 0 times A is 0, and so we don't need to add it with anything. We're just going to put the 2B plus 4C. Now, this should kind of remind you of something here. A plus 2B plus 3C, 5B plus 7B plus 9C, 2B plus 4C. I hope this reminds you a little bit of systems of equations. Now, we don't have an equal something here, but it sure looks like it's the beginnings of a system of equation. And there is a strong link, and we'll get into that in just a few minutes. So here is what we're doing. Consider a matrix equation where you have an n by n matrix multiplied by an n by 1 matrix. We're going to call this a coefficient matrix and this a variable matrix. We'll talk about that later. Can we multiply these matrices if they have these dimensions? One is n by n and one is n by 1. Can we multiply that? The answer is yes, because the middle dimensions line up. And what are the dimensions of the result matrix going to be? Well, it's going to be the leftover dimensions, n by 1. So we can multiply them. Now, what we're going to want to do is solve. There's actually, guys, there's a whole class, college class, on matrices called linear algebra, and this is considered a simple linear equation in matrix algebra. And what we want to do is we want to solve for x. And if you recall, last class we talked about how there is no matrix division. You can't divide by a matrix. So if this was algebra 1, and we were trying to solve this, we would divide by A, and that's how we would get x by itself. But with matrices, you can't divide by a matrix. Instead, we're going to use a different trick. We are going to multiply by the inverse matrix on both sides. So I will show you this. We're going to multiply on both sides, and it actually matters the order you multiply by with matrices. So we're going to multiply on the left. Since we need to multiply on the left here to multiply times this, we also need to multiply on the left of B, have it be the same on both sides. Now, recall, if you multiply an inverse matrix with a matrix that it's the inverse of, you always get the identity matrix. So this will be the identity matrix times x. And this will just leave as A inverse times B. And guys, up above, the fact that this multiplied together to make the identity matrix meant that these were inverses of each other. That this was a matrix and this was the inverse of that matrix. So the fact that it multiplied together to make the identity is an easy way to check to see if two matrices are inverses. So these are inverses because they multiply to give an identity matrix. And there's another special thing about an identity matrix, which is that if you multiply an identity matrix times another matrix, it just gives you that answer matrix. And so notice we have now solved for x. So the way we solve for x in a matrix equation is we multiplied on the left side by A inverse, and then here this will become the identity matrix, which just it's like multiplying by 1, and it multiplies times to give you just x. So this will solve a matrix equation. We will come back to this in just a second. Let's figure out, so we know how to solve a matrix equation. We multiply by A inverse, and a shortcut way of thinking about it is like, hey, A inverse is going to end up canceling out with the original matrix, and you'll just get x equals A inverse times B. So it's kind of like dividing. So let's talk about how to change a system of equations into a matrix equation so that we can use this new skill of solving a matrix equation to solve it. So our idea is going to be that we're going to change a system of equations, this has 3 variables and 3 equations, into a matrix equation. And what we're going to do is we're just going to put the left side into a matrix and the right side into a matrix, and we're going to have to say that they equal each other. X plus y plus z is going to equal 6. Y plus z is equal to 5. X plus 3y is equal to 7. And this works because if these two matrices are equal to each other, then the elements must be equal to each other. X plus y plus z must equal 6, y plus z must equal 5, and x plus 3y must equal 7. This is another way of writing the same system of equations. I hope that's clear. Now here's the slightly tricky part, is we are going to change this 3 by 1 matrix into a 3 by 3 matrix times a 3 by 1 matrix. I hope you see that we'll be able to multiply 3 and 3, and the answer will be this 3 by 1 matrix. And what we're going to do is we're going to call this the coefficient matrix. And I hope we know what coefficient means. Coefficient means it's the number that is in front of the variable that's multiplying by it. So what number is multiplying times that variable? So the coefficient of x here is 1, 1x. The coefficient of y here is 1. The coefficient of z here is 1. And now instead of having a single entry in the row, we have 3 columns. We've changed this into 3 different columns. The coefficient of x here is 0, the coefficient of y here is 1, and the coefficient of z is 1. What is the coefficient of x here? And what is the coefficient of y here? And what is the coefficient of z here? Hopefully we know that we remember from our warm-up how when we multiplied these times variables, we ended up with something that looks like a system of equations. And that's what we're going to do here. We're going to take these variables and put them in order. X, y, z. That way when we multiply the row times the column, we will get 1x plus 1y plus 1z as we have right here. When we multiply the next row, we'll get 0x's plus 1y plus 1z as we have right here. So that's how multiplying a row times a matrix works. And the answer matrix is still going to be this one, 6, 5, 7. And now we have a matrix equation. A times x equals b. And we talked just a second ago about how we can find what the answer matrix is. We multiply on the left side by A inverse. And so we're going to multiply by A inverse. We don't have to write it on the right side if we don't want. Times b. Okay. Now, it turns out that finding the inverse of a matrix is a lot of work. As long as, if it's not a 2 by 2 matrix, it's a lot of work. But calculators are amazing at this. So we're going to use a calculator here to do it. And here is what we're going to do. We are going to use this. Guys, if you don't have this calculator or a calculator like it on your phone, go download one now. It's on the main page of our blend. So you're going to press second matrix. There's a matrix button right here. And the first thing we're going to do is we're going to go over to edit. So we're going to press over until we get to edit. And we're going to edit the first matrix A. We have to say what dimensions it has. It is a 3 by 3 matrix. So we're going to type in 3, and press enter. And we're going to put in what is this matrix. We're going to type it in. 1, enter, 1, enter, 1, enter. Notice it's every time I press enter, it just moves on to the next one for me. It's nice. 0, 1, 1, 1, 3, 0. Double check to make sure this actually is the matrix that is here. Because guys, you should be doing this along in a calculator with me. I'm going to ask you for what the answer is before I put it in. And if you haven't done it in the calculator, it's not going to come out right. So again, second matrix, go to edit, put in the dimensions. This is 3 by 3. So we're going to put in matrix A. Now, we also need to put in matrix B. So go to matrix again. We're going to go to matrix B. And this one is a 3. Oh man, hold on. Second matrix, edit, matrix B. And this is a 3 by 1 matrix. Good. 6, 5, 7. That's what this matrix is right here. That's matrix B. And then we're going to quit to go back to the main home page. So quit is right above mode. So you press second, quit, get you back to the main screen. And we are going to type in what x is equal to. These variables are equal to A inverse times B. And so the way we get to that is we press second matrix. Do this with your own calculator, second matrix. And we're just going to press enter on A. Press enter. There's A. The inverse button is right above the matrix, is the same button as the matrix, you just don't have to press second to get to it because it's not in blue. This x to the -1 power is the inverse button. So A inverse, then we have to put in matrix B. So A inverse times B. So second matrix, we're going to go down and press matrix B and press enter. And this will solve the system of equations for us. Now, the matrix is, so I'm going to rewrite what the actual matrix is. The actual matrix was x, y, z. That was the variable matrix, is equal to 1, 2, 3. And now we can see that x is 1, y is 2, z is 3. That is the solution to the system of equations. Now, could we have solved this analytically? Yeah, we could have gotten x by itself here, substituted, solved. It would have taken about as long for this one, maybe a little bit longer to do it analytically. The calculator is going to get really fast. So let's formalize what happened here. Notice when I changed it into a matrix equation, I was careful to line up the variables. That's because the coefficients have to go in the same order. They will all be multiplying times x, then y, then z. X, then y, then z. X, then y, then z. And so you have to put the variables in the same order. X's, line them up. Y's, line them up. Z's, line them up. And then the coefficients go on the left. So let's look at how this looks with a fresh system of equations. Our first step is we need to line up all the variables on the left side and all the constants on the right side. So what we're going to do is we're going to take this. Are all the variables on the left side? Well, y is, but x is not. So we need to subtract 2 x's on both sides. This is going to be equation 1. And I'm going to put that right here. And when I subtract, I'm going to put x's, then y's, then z's, and I'm going to make sure it's in the same order each time. So y minus 2x, but I'm going to put the x's first. Negative 2x's plus y equals 3. And I left a blank spot for z here. I strongly recommend it. The next one, which variable is not where it's supposed to be? Hopefully we notice z is not where it's supposed to be. Z is supposed to be on the left side, and so we're going to subtract z on the left side. This time, I've got y minus z, and remember I'm going x's, then y's, then z's. So I'm going to leave a blank spot for x, I'm going to put the y, and I'm going to put minus z equals, the constant is still left over here, negative 49. The last one, all the variables are already on the left side, and the constant is already on the right side, and I'm just going to rewrite it so that all of these are together. I've got the constants on the right, all the variables are on the left, and I've double checked to make sure the x's line up, the y's line up, and the z's line up. What I can do is I can now convert this into a matrix equation. And the way to do it is I'm going to put the coefficients times my 3 variables in order, x, y, z, equals the constants, 3, negative 49, 180, and I'm going to put in the coefficients. So what are the coefficients of x, y, and z for this first equation? Hopefully we see it's negative 2. That's the coefficient of x. The coefficient of y is 1. And there are no z's, so the coefficient of z is 0. Notice when we multiply this row by this column, we will get negative 2x plus 1y plus 0 z's. Negative 2x plus 1y plus 0 z's. What are the coefficients for the next line? Hopefully we can see it's 0 x's, 1y, and negative 1 z's. Okay. What are the coefficients for the last line? 1, 1, 1. There's 1x, 1y, 1z. All right, so we converted it in, we moved all the constants to the right and the variables to the left lined up. We have converted to a matrix equation. Now we need to type it into the calculator. We're done with stuff on our paper. We're now just doing stuff in the calculator. So again, we press second matrix. We're going to edit that first matrix. This is a 3 by 3 matrix, so we're going to put in matrix A. This is matrix A. this is matrix B, this is matrix X. And we're gonna put in the coefficients, so -2, 1, 0. Guys, make sure you're doing this along with me. I'm gonna ask you for the answer in a second. 1, 1, 1. Double check to make sure you've actually entered them in right. This is the number one source of errors, is people just like messing up putting in one number. So then we're gonna press second matrix again, and we're gonna edit matrix B, which is a 3 by 1, good. And the constants are 3, -49, 180. We're gonna quit back to the main page, and we're gonna type in second matrix A, inverse, which is the matrix button without pressing second. And then we have to press second matrix B, B. And when I press enter, it will tell me the solutions for what X, Y, and Z are equal to. So X is equal to, Y is equal to, Z is equal to. We'll be able to see it right away. X is equal to 25, Y is equal to 53, Z is equal to 102. You know, if you didn't get these, you might want to go back and check earlier in the video where you messed up because you want to understand this, okay? Guys, this is a 5 by 5 matrix, or sorry, this is a 5 variable system of equations. This would take me like, I don't know, 10 minutes to do. I suspect it would take you guys like half an hour to do, but with a calculator, it's still only gonna take about 2 minutes. So we're gonna line everything up on the left side first, right? This first equation, what variables are not lined up on the left? None, they're all fine. A plus B plus C plus D plus E equals 15. Our second equation, what variable is not lined up on the left? The B's, we need to do minus 2B on both sides. And we need to be very careful to put it in the right order. We're going A, B, C, D, E. So we're gonna go negative 2B first, leave a bunch of blanks, and then put plus E. So this is negative 2B plus E equals what? What goes on the right side? That constant is still 1. We leave the constant to the right side. D equals 4A. What variable isn't in the right spot? Well, it's the 4A. So we're gonna put minus 4A, minus 4A. And we've got D minus 4A. We gotta put them in the right order. So it should be negative 4A lined up under the A's plus D lined up under the D's equals, when we subtracted 4A, what is the constant that's left over there? Well, this is 0. 4A minus 4A is 0. There's no constant left over, and so we put equals 0. E minus C equals 2. Well, this is, all the variables are on the left side, but what's wrong here? Well, they're not in the right order. I need to put the C's lined up with the C's, so negative C plus E. So the C is negative, not the E. Don't put C minus E. E minus C does not equal C minus E. E minus C is negative C plus E, and that's equal to 2. And lastly, these are in the right order. A plus B, oh sorry, yikes, A minus B plus C minus D plus E equals 3. Okay, now I'm ready to do the coefficient matrix. Guys, I'm gonna tell you, you can go straight to the coefficient matrix. Like you can go straight to putting this in if you want. Let's go to matrix, so second matrix, and we'll go to edit. What size matrix will I need here? Well, there's 5 variables and 5 equations, so matrix A will need to be a 5 by 5 matrix. And I'm gonna just write the coefficients from the first line here. What are the coefficients for that first line? 1, 1, 1, 1, 1, 1A, 1B, 1C, 1D, 1E. What are the coefficients for the next line? 0 A's, negative 2 B's, 0 C's, 0 D's, 1E. What about for the next one? Negative 4 A's, 0 B's, 0 C's, 1 D, and 0 E's. The next line is going to have 0, 0, negative 1, 0, 1, negative 1C, and 1E, and the rest are zeros. And last, we've got 1A, negative 1B, 1C, negative 1D, and 1E. That is our coefficient matrix. So that's going to be matrix A. I also need to put in matrix B. So matrix B, I'm going to edit and put in the constant matrix. What size matrix does this need to be? 5 by 1. So 15, 1, 0, 2, 3. And last, I quit back to the main screen. I press second quit, and I'm always going to put second matrix, A inverse B. A inverse times B. That's what we do to solve our matrix operation at the end. And it tells us in order, A is 1, B is 2, C is 3, D is 4, and E is 5. So let's put that. A is 1, B is 2, C is 3, D is 4, and E is 5. That is the solution to our system of equations. If we plug these in, it makes all the equations true. Like for instance, this one, E minus C equals 2. E is 5. 5 minus 3 is 2. All right, guys, that is it. You'll get some practice on this, guys. Make sure you get some practice. You want to feel comfortable with it and have gotten enough practice that you don't forget what buttons to push. Again, the big idea here is we get all the variables on the left side and line them up. Next, we'll be able to convert it into a matrix equation where we take the coefficients and put them into a matrix times a variable equals the constants. And then to solve this matrix equation, you multiply by A inverse on both sides, and A inverse will cancel out this matrix and get you what the variables are equal to. X is A inverse times B. That's it. I hope you find that this, this took, I don't know, 2-3 minutes, whereas doing it by hand would have probably taken you about half an hour. Feel free to try it by hand. Feel free to try this using substitution. It takes a while. Have a good rest of your day, guys.